Good morning. This is a continuation of the previous class on verification validation, the fourth unit, which you people have to thoroughly prepare for the I number 3. And you all people know about that. The semester end exam is based on, a new question paper format. Unit wise, in every unit, you will have two questions and you have to answer any one. This is the format in which you'll be doing it for all examination, right? So every unit is important. If you skip any unit, you are skipping 20 marks straight away, right? Don't do that, because every unit is important from placement perspective, career perspective, knowledge perspective. So we were discussing about the equivalence partitioning, right? We referred about the path testing through the control flow graph CFG, where basic blocks have been used. Then we referred about the statement testing. If every node is covered, right, then it is a statement is all statement in that particular node is being covered, right? Then we were referring about the coverage. Coverage is, for example, coverage for statement, coverage for path, coverage for condition, coverage for branch, coverage for everything. So what is the coverage? Okay, for example, statement, you take it, right? The statement coverage refers to total number of statement executed divided by total number of statements available into 100. That's the percentage of coverage. This is the aspect that we have covered, right? Are you okay with this? Are you okay with
Yes,
this?
sir.
Whatever the marking that I have done, and let's refer a little bit of the in-class like question bank. In-class question bank, right? Your CRs have updated that, and a little bit aligned that one also. Please look into that. Okay, we'll have look at in-class question bank. Is this okay, visible? Is it visible?
Yes, I did.
Yes, it is.
Right. Let me take you quickly through. Uh, just a minute. Let me take to the verification and validation aspect of that. Yeah. Right. So look into that. What all the things have been added. Okay, is what is testing. Okay. Now, what is testability? Explain with example the programming paradigm that explains testability. All right. Right. What is the use of basic block? Explain with the example. Or prepare the test cases with 100% path coverage for the following code. Use control flow graph and cyclomatic complexity number to identify the number of paths. Right. This is an example. Whatever the code that is given, such kind of questions you can prepare, think, and do it. Look at that. Find the cyclomatic complexity number for the given programming segment. Any programming segment, right? And study material have been added. Right here, you can read it. Right, how basic block, how control flow graph is being constructed. Right, what is the basic block? Right, then example. Right, this. Right here is being given. And question in the image. Right, look at that question in the image part 2. Consider this example, right? Find the equivalence partition for the following exercise. This exercise I have given. Please contact your seniors currently who are in 7th sem and study this, right? And this is an important thing he has highlighted with the red color. Right. Now, similarly, now look at that. I've added two more examples. Right. Consider an application that requires two integers, x and y, and which will range, okay, x and y in this particular range. Right. Prepare an equivalence class, because now look at that. There are two variables are involved here. A single variable equivalent partitioning is all right. Say, for example, right here, I'd like to tell you. If you see here, I'll put a marking on that. Now consider that you have an x in the range integers, right? Okay, x lesser equal to 7 and x, right, greater than 3, right? So you have x values 1, you have a 2, you have a 3, right? Then you have got 4, 5, okay, 6, 7, right? 8. So it grows like this. Positive infinity, it is negatively grow like this, right? Where it is a 0, -1, minus 2 like that. If you take a single variable, fine. Now look at that 3 less or equal to x. That means, right, and x less or equal to 7. That is 3 to 7. This is one partition, valid partition. Do you agree? All of you, do you agree? Do you agree? Partition P1. Do you agree? Ashish and Arpita.
Yes, sir.
Right. Then another partition is anything that goes beyond this. This is partition P2. Right? Now look at that. Anything less than this, that also you need to consider. It is open. Right? Anything here. It is also open, anything here. Right? This is partition P3. There are 3 partitions that you will find if there is one variable is concerned. But if at all 2 variables are concerned, it may show up on that. Now consider y. Similarly, y, right? 5 less or equal to 7 less or equal to 9. I'll say that one, right? One of the partition here is okay between inclusive of both 5 and 9 because less or equal to is there. This is the partition, right? You can say okay P3 or P4, and this is another thing okay P5, right? And this is another thing where which is open here P6. But if you take only one variable, right, say x, right, there are 3 equivalent partition. If you take y, there are 3 equivalent partition. But if you take x and y together, right, we don't know how the things are being formed, programs are being written. X and y, okay, totally you have a 3 into okay 3 equal to 9 equivalence partitions. Do you agree with that? Do you agree with that? Right? Do you agree?
Yes, sir.
Right. What are those properties and all? Right. Please study that one. Right. This is only limited handholding I am giving you, not a complete solution. Right. For this, I'm sorry. For this, right, I'm not given a solution at all. This for that limited solution. Right. Now there is one more case study. Okay, please look into that. This kind of things will enable you to think better. Right? So this also you consult your seniors and try to work on that. I will not work on that. This case study, this exercise. I wanted you, all of you, thoroughly study all these things, okay, and then get into final exam, semester end exam, as well as the third IE. For that, some details are given to you as a study material, a system which appears like that, what are the different variables. Now there are 4 variables available. For every variable I have given what type of variable are that, what are the possible values it can take. For example, we can take a value either a file or GUI, F can take a value, okay, a file name, right? Command can take, there are 3 commands, and temperature can take -10, -5, 5, 10, and one is invalid. These are all valid and invalid, right? Right? And you have been asked to work on that. Are you getting this? Please, okay, study this, create a solution and get into it. Right? Like this, the question banks are being prepared. And when we were talking about the coverage, in this case, statement coverage. In case of path is a path coverage. What is the meaning of coverage is okay, number of executed statement divided by number of total statements for statement coverage. For a path, it is a number of path executed divided by total number of path available. For condition, it is a number of conditions executed divided by total number of conditions. Right? So when you have a test case, a possible combination of input, right? What all it covers that you need to look into. And examples were given, if I'm right. Right? For the given following problem, identify minimum number of test cases to ensure 100% of the 100% coverage of the following: statement coverage, decision coverage, condition coverage, path coverage, etc. Right? And the example given is this hint. Right. And here is one example, okay, which we will work on conditions. And these are the test cases. Right? So shall we get into this example? Ashish, Arpita.
Yes, sir.
That's good. Right? That's good. We get into that. And We'll take an example. Yeah, this is an example. Now if you listen carefully, right, this is the solution, and we have a problems here, problem statement, not problem statement, right? This is given as a problem statement, right? You need to design the test cases so that, right, the 100% condition coverages are taken care. Now, what do you mean by condition? This entire thing is decision. Say, assume that if you are written a program, if, right, open bracket totally, bigger one, if this is the case, okay, then do S1, open flower bracket, close flower bracket, then else, open flower bracket, close flower bracket, this is statement S2. Now, what is the decision? Decision is, right, this whether you are executing, right, oh, right, one minute, I'm sorry, 1 minute, I'll change the color, right. So, whether you are executing this or your else part, that is addition, right? This entire thing constitute addition. Whereas, right, each one of that, this is the condition, whether A is true or false. B, whether true or false, this is the condition. And put together, this is another condition, A or B. Now, C is another condition, right? This condition, I'll call it as a C1, I'll call it as a C2, right? C1 and C2, that is a condition, right? D is a condition, right? C3 condition. Now what happens is this condition I will call it as a C4. C4, right? Right? C4 or C3 is another, right, condition. That's, let's call it as a C5, right? Then we have a E. This is a C6 column, right? C5 and C6. That becomes totally C7. That's another condition. So this entire condition C7, right, if it is true, we have taken a decision, right, we are entered to S1. Hope you understand the meaning of conditions. Arpita and Manoj, sorry, Ashish. And
Yes, sir.
right. Now look into that. I'll discard all the things, right? See, look, right. Now I want to build the test cases. How do I build the test cases? Please understand this. Right. So what to do is, right, see here, right, this entire thing, if this is true, right, then possibility that one, this is a true and false. These are two things. Right. Now this entire thing is true, right, then there is a possibility that this is true or false. This entire thing is true, right, then there is a possibility that this is true or false. Hope you all understand that. Very clear about this? Very clear about this?
Yes, sir.
Right. Now let's look into the smallest part of that, okay, which I did not cover in my previous marking. Right? Now look at that. If this is true, it doesn't make a sense whether this is true or false. Right? So entire this condition is true. Am I right? Do you agree? Do you agree?
Yes, sir.
Right. So that's what is being seen here. Now look at that. When A equal to true, and small part I'm explaining, it doesn't matter whether B is true or false. Do you agree?
Yes, sir.
Right. And if A is true, this entire thing, whatever I am marking here, entire thing is true. Right. Now C has to be true. Right. In order to make this entirety is true. Do you agree?
Yes, sir.
Right. Look at the marking. Now, when entirety, the entirety, whatever I'm showing here, red color, if that is true, right? Wait, what has happened? Right. No, 1 minute. Right? 1 minute. one, so take a marking. I use different software, so I get confused, okay, with options of one with other thing. Now look at that. Here, right, here is the one thing. If this entire thing is true, if this entire thing is true, here, this equivalent of that, it doesn't matter, no, because it's a or. Okay, this is, you can ignore it. Do you agree? Do you agree? Do you agree? Ashish, Arpita.
Yes. Yes.
Now, thing is that, okay, whatever I've shown, this is the entirety here that you are seeing here. Now, E can be either true or false. Now, look at that. True is being given here. Where exactly false is given, can you look into that? Can you look into that? Where is the false? See here. See here. Do you agree? Do you agree?
Yes, sir.
Right. That means, right, that means this entirety, right, it may be true, right, that you are seeing in test case 1, test case 6. And E can be true, in case of E can be true, what happens? Right? Statement S1 should be executed. The body of that. In case of E is a false, what is that? Statement else part, the body that is called S2, that is to be executed. If this is the if statement. Do you agree? Arpit and Ashish?
Yes, sir.
Right. So looking at this, you need to build a test cases. In this case, right, as many as, okay, the 13 test cases have been built, validated, check it whether it is correct or not. Anything that is given in the book, right, don't take that one that is correct by default. No. You need to verify, you need to build and just look into that. And in the examination, such kind of things will be given to you and you prepare a test case. These are the test cases. Right? Value of A, B, C, D, E such that they evaluate to be true. In this case, we have simply given A, B, C, D and all. It could be actual expression in C language. C language expressions. Of course, in any language. Are you clear about that?
Yes, sir.
Yes, sir.
Right. Now, shall we look into the other aspect? When you dissect this one, right, there are two things. Okay, let me call this as left hand side. Let's call this as a right hand side. And there are only two parts, and it is being left hand side, logical and with the right hand side. Right? Logical and with the right hand side, all true things you will see here. Do you agree? Arpita? Right. And okay, right hand side, all false things you will see it here.
Yes.
Okay, na? Is it okay? Is it okay?
Yes, sir.
Right. Now look at that. This. Then what about this? Okay, the values we don't care whether true or false. We don't care. We don't care true or false. This if this entire thing result into false. Do you agree? Left hand side false and right hand side doesn't make a difference. You know, false and whatever it is there false only. No. Do you agree?
Yes, sir. True.
Okay. When exactly the left hand side will go false? Look at that. Right? Left hand side will go false. Look at that here. Right? This, within that I'll call this entire thing, left hand side there are two parts. This I'll call it as L1 left hand side, and there is one more here. This is I call L2. Do you agree? Left hand side there are two parts, L1 or L2. Can you visualize? Arpita, Ashish, can you visualize?
Yes, sir.
Right. Now look at L1 and L2. L1 or L2, right? when it can be false, when both are false. Do you agree? Or is there?
True, sir.
Right. That means L2, this is false. You can see. That means D is false. Now coming to L1, right? In that again there are sub expressions. A or B and C. When this can be false? When, right? When it can be false. When it can be false. When A or B is true, A or B is true, look at that, A or B, right? When A is true, doesn't matter what is B, that means A or B is true. Then C will be made false, so that entire thing is false. Do you agree?
Yes, sir. Yes, sir.
Right. Now look at that. When A is false, right, B will be true, right? There is a possibility, right? Then, okay, C will be false, then entirety is false, L1, right? When A and B both are false, it doesn't matter whether, okay, C is false or not. This entire combination of L1 can be visualized in terms of this, like recursively you have to get into and build, okay, test cases. Right? Redundant things you should not write it. For example, the test case number 13, you look into that. When it is a false, A is false, B is false, you should not write, yeah, okay, C is false once and C is true once, because it doesn't matter. They're a redundant one. Instead of two test cases in place of test case number 13, please refer. Instead of writing it twice, we are writing only once by making, right, C is dash. Ignore. Do you agree? Otherwise, with value of C, you will be writing twice the statement number 13, which is incorrect. Do you agree?
Yes, sir.
Please,
Yes, sir.
okay, take a screenshot of this, all of you. Yes. Any question at this stage? Any question at this stage? Any question? Okay, at this stage, I am waiting for you to go through. The more complex conditions you put it, right, it becomes very complex to build test case, because any one of the possibilities, right, it may fail and your logic may go wrong. So if this is the if statement, in case of a white box testing in the sense of white box or glass box, it means that code is made available, you are testing. In case of the black box, right, code is okay, not, you are not seeing the code. The executable is made available to you, you are looking at the requirements and you are validating against the requirements. Ashish, you can note down, explain the following term, right? Black box testing, white box testing. Ashish, you can note down, add in your in-class
Yes.
plan.
Yeah,
Explain the
yes, yes.
following term. Explain the following term. Glass box testing, Roman 1, Roman 2, okay. Glass box, white box, glass box slash white box. Second one is black box.
So, what is the first one?
White box slash glass box testing.
Okay.
Second Roman one is like black box testing.
Yes, sir.
Third one is difference between validation and verification.
So difference between.
Validation and verification, Roman third. Roman fourth, five, six, we keep on adding all the things. These are different terms. Right? Test script. Next one. Test script. Roman 4. Test script. Next one. Roman next one. Test procedure.
Yes, sir.
Next one. Alpha testing.
Yes, sir.
Testing. Next one. Beta testing.
Yes, sir.
Next one. Unit testing.
Sir.
Unit. UNIT. Unit testing.
Yes.
Next one is okay. Integration testing.
Yes, sir.
Next one is acceptance testing.
Yes, sir.
Next one, okay, is load testing.
Mode, sir. MODE.
LOAD, load testing.
Yes.
Then next one, stress testing.
Stress.
STRES, stress testing.
Okay.
Next one is model based testing.
Yes.
Next one is equivalence class testing. Equivalence class testing.
Yes, sir.
Boundary value analysis.
Sir.
Boundary value analysis.
Sir. And can you spell it, sir?
Boundary value analysis.
Oh, binary. Okay.
Boundary.
Boundary. Okay.
Sir, boundary value analysis,
Yes, sir.
right? Then, okay, what I can say is path testing,
Sir.
PATH, path testing.
Yes.
Then, right, statement testing,
Yes.
condition testing,
Yes.
decision testing,
Yes, sir.
cause effect graphing, cause effect graph. That will
Cause.
cause effect graph.
Okay.
We'll all study all those things one by one. Some of these things already we are studying. Right? Is it okay? Right? All of you, is this okay? Any question at this stage? Any question at this stage? Any question at this stage? Okay. Now shall we get into the another one? Right? Shall I close this?
Yes, sir.
Yes.
Okay. Now what we'll do is we will take one example about the next one is right boundary value analysis. We have covered the equivalence partitioning, statement testing we have done it, path testing we have seen through control flow graph, right? Right. Then we'll look at the boundary value analysis right now. Please look into that. In this week we will do all testing related things, and condition testing we have done it. The condition testing we have done it, right? So now we'll look at the boundary value analysis today and we'll stop. Then in this week, we will complete the remaining part of that. And next week, we will dedicate only for, okay, the unit number 5. Right? Until exam begins. Exam begins on 26th. Right? Next 2 weeks, right, we'll keep it for unit number 5. Ashish, is it okay?
Yes, sir.
Then afterwards you will have a third IA. Then once third IA is there, then until you are called here for physically for semester and exam, revision will begin. For all courses, you have to consult all your teacher to revise until you come physically here.
Yes.
It is true. There won't be any separate notice. Okay, CRs, you have to talk to all people, right, and ensure that. Okay? Right.
Yes.
Now let me talk about the boundary value analysis here only. Right? See, all of you look into, right? See, okay, consider the statement if, all right, if, right, A greater than 80, greater or equal to 18, right? Then this is the pseudocoda. Please don't ask that. This is not a C programming language. Then I will open the bracket. The statement S1 is executed. I'll close the bracket. S1 is set of statements. Then else, right? Open flower bracket. The statement S2, set of statements S2 is being executed. Is it clear?
Yes, sir.
Now consider that this is the okay block of the code we have it. Then when we talk about the right the equivalence partitioning, now look at the A. I'll write it here A. Right? Here A is minus 10. Like that it gets into. Then I will say that one greater or equal to 18. No, up to 17 I'll write it. Okay, assume that all numbers between that 18, then you have a 19, then you have a 20, right? It grows positive infinity, negative infinity to positive infinity. Infinity is okay, something a large number, that's all, which you cannot visualize. Right. Now, when I talk about the equivalence partitioning, what I do is, right, greater or equal to 18, right? So this is one partition, right, all positive infinity, and this another partition, right? How many test cases are there? T1 and T2. Do you agree? Do you agree?
Yes, sir.
But now what happens is, right, the mistake here, you wanted to, okay, realize the mistake. Realize the mistake. Okay, it may so happen that, right, instead of writing greater or equal to, you might have written greater than 18. In that case, assume that you have selected a sample 20 from T3. It doesn't reveal that one you have wrongly put greater symbol instead of putting greater or equal to. Do you agree? Do you agree?
Yes, sir.
Yeah. In that case, what suggests the boundary value suggests is that you go for equivalence partitioning T1 and T2. On the top of that, whatever boundary is there, no, okay, immediate adjacent to the boundary, take sample from that also, right? That means I'll take 18 as one test case and 17 as one test case. This is T3, this is T4, right? Now, right, all T1, T2, T3, all must be executed correctly. Then only it indicates that greater or equal to the proper symbol has been put. For example, instead of greater or equal to, you put a greater than 18. Now look at the boundary. This is the boundary, you know. I told you this is the boundary. Just adjacent to that, okay, I will be picking 18. Now 18, it fails. 18 fails. I am supposed to put greater or equal to, and it should execute S1, but by mistake I put a greater so that S1 doesn't execute, it goes to S2. That means this boundary value will reveal that one, this operator is being correctly put or not. Do you agree? Do you agree?
Yes, sir.
Yeah. Now, what is the purpose of the boundary value analysis? Boundary value analysis strategy to ensure that Operators are used correctly when you are making a condition, when you are writing an expression. Otherwise, a sample 20 having selected in equivalent partitioning, it executes correctly. Whether it is a greater or equal to or greater doesn't matter. Correct thing is greater or equal to, but you put a greater and your sample input is 20. It shows S1, so you decide that the program is correct. But it is not correct. And many times we write greater or equal to. We do all this mistake, Ashish.
Yes, sir.
Right. Any question at this stage? But the boundary value by taking 17, what happens whether you put greater or greater equal to? Does that makes a difference? 17 greater than 18, no, S2 is executed. 17 greater or equal to 18, no, S2 is executed. So the lower part of this boundary value doesn't, have any impact on greater or equal to. Had it been less or equal to, then it makes a difference. Remember. Are you clear?
Yes.
Clear.
Yeah.
Arpita, the floor is open.
Yes, sir.
Yeah, good. The floor is open for everyone. Anybody can unmute and ask me question if not understood. See, in the next class on Wednesday, I'll be taking cause effect graphing. Then on Saturday, I'll be taking some generic fill in the blanks. Next week, I'll be taking on data flow testing. And that's the end of, no, sorry, data flow testing also this week only I'll complete, right? So on Wednesday, I'll be taking cause effect graphing, test generation from predicates, branch, okay, all the things. Branch testing, path testing, I'll simply have covered. Then Saturday, right, I'll be taking a data flow testing. So that next 2 weeks are reserved for, right, the unit number 5. Is that clear? Any question at this stage about the boundary value analysis, right? Not on the question, Ashish, in our in-class question bank.
Yes.
Right. Prepare a scenario
Yes, sir.
and explain
Explain
how
how
boundary value analysis
boundary value analysis.
reveals the error
Yeah.
which could not be identified by equivalence partition.
Which could not be identified
By
by.
equivalence partition.
Yeah.
Look at that. Writing answer, there is an intelligence required here. Right? This is the example. If A greater or equal to 18, then S1 equals S2. Now equivalence partition you show it. And to consider equivalence partition in sample empty. Right? And now assume that by mistake, instead of writing greater or equal to, you have written greater. And your test case is executed properly. You say that everything is okay. But greater or equal to, that is a mistake. You didn't do it. So you go for boundary value analysis. Now boundary value analysis, I'll take 18, which will, okay, S1 will not be executed, S2 will be executed. So it will detect the mistake in operator greater or equal to. So this is the kind of an answer you need to write. Ashish, I'm okay here? I'm audible?
Yes, yes, you are.
I told you how answer is to be written. So
Yeah.
book will not help you to write the answer for this.
Yes.
I want everyone to refer whatever the video I'm telling, please refer it. Right?
Yes.
And sometimes you can take a screenshot also.
Yes.
Got it. So the meeting is getting closed in next 2-3 minutes. Right? If you have any questions, I would like to answer. So we have covered today few exercises on equivalence partitioning, right? And boundary value analysis, we referred it. Right? Whatever the yellow mark you see, of course, the beginning, but the terms and all, what is the meaning of that? All that is taken care. Right? So, unit number 4, white color things we would like to cover in next 2 classes of this week. One is cause effect graphing, right, and other terminology like predicates, branch testing, and all. Then we'll get into data flow testing, okay, on Saturday. Are you clear about this?
Yes.
Build your own example for equivalence partitioning, boundary value analysis, cause effect graphing, right, statement testing, condition testing, branch testing, path testing, etc. Path testing and branch testing will go together because every branch is a path, you know. Do you agree?
Yes.
Every branch, right, that is decision testing. Okay, entire condition, set of condition together becomes a decision. The decision, okay, takes you to branch, and every branch leads to a path, right? But anyway, we'll refer it. So with this, I would like to close my today's session. Is it okay? Is it okay?
Yes, sir.
Right. I wanted more number of people to participate, only 42 people. Anyhow, I'll put a video and you can refer the video. And if you have any, okay, questions, understanding more required, you can interact with me, right, or arrange a session, okay, by talking to CR. All students, if at all you need any clarity, please interact with the CR and schedule extra class in the evening. I am open, right? Maybe evening around 6 o'clock we can have extra class if required. From today onwards, anytime. But CR has to schedule it and he should inform me. Shall I end my meeting today? Shall I end my meeting?
Yeah. Yes, sir.
Arpita, shall I end my meeting?
Yes, sir.
Right. I am giving example. Please remember in the examination, okay, along with the theory, examples you have to prepare. Right? Please remember. Right. Okay. Thank you. Bye. I'll end my meeting.